Hello, this is Wang Xizhi from Hangzhou Foreign Language School, Hangzhou, China, and I'm here to talk about my summer holiday project, which is the homemade street pipe Coriolis Mass Flowmeter sensor. This video is not going to be a tutorial, so if you're not familiar with the Coriolis Mass Flowmeter sensor, then, well, there are lots of very good videos online, so if you're interested, maybe you can watch them before or after this video. If you're familiar with the Coriolis Mass Flowmeter sensor, then you might know that it can have many kinds of shapes. Today I'm going to talk about only one of them, which is the street one in the red box. The advantage of this is that it can have very low resistance to the mass flow inside it, so the actual speed of the mass won't be affected too much. If I've ever seen a picture of Coriolis Mass Flowmeter sensor, you will see a large metal box and you can't see anything inside it. Some people might think that it might be very complicated. Well, actually it's not. The main components are quite simple. Just a tube, obviously, because you need to have mass flowing through it. And then there's a driver used to brace the tubes, and two sensors used to detect the vibrations. Let's talk about the materials that I used. Well, for the tube, I chose stainless steel because, well, first it's hard enough, then it's cheap enough. The picture here is just a screenshot from the website on which I bought the tube. Well, it's in Chinese, but don't worry about it. It's just talking about the price and the quality and all kinds of data about it. Then there's the driver and sensor. And usually for a Coriolis Mass Flowmeter sensor, the driver and sensor are specially designed, but I don't think they are available online as a product because, well, I mean, who would buy a driver and sensor that can only be used on a Coriolis Mass Flowmeter when you can just buy the Mass Flowmeter itself? So instead, I'm going to use speakers, both as driver and sensors, and it will be using two scientific principles. Well, in the driver mode, the speaker uses Fleming's left-hand rule, which is just how a speaker normally functions, so there's not too much to talk about here. But in the sensors mode, it uses Fleming's right-hand rule, which is actually just the reverse of Fleming's left-hand rule. You input vibration and it will output electronic signals, which is, well, current. And then there's the dual-channel amplification module. We need this component because, well, the signal we get from the sensor is actually very weak, too weak perhaps, to be detected and stored by the data acquisition module. So we need to amplify it to make it stronger. Next is the 8-channel data acquisition module that I just talked about. Actually, we only need 3 channels, 1 input for the driver and 2 output from the sensors. But I don't think there are quite a lot of 3-channel data acquisition modules online, so I just bought this 8-channel one. And it can collect 8 samples simultaneously, so I don't need to worry about the phase difference caused by the data acquisition module itself. And it has a maximum of 100 kHz sample rate, which is more than enough for us because according to our anticipation, the resonance frequency of the tube is actually around 700 or below 700 Hz. So I think we can have a precise enough sample. And this is the datasheet of the ADC converter on the 8-channel data acquisition module. And it says here clearly that it can have 8 simultaneously sampled inputs, so I really don't have to worry about the phase difference caused by it. And then there's the sine wave generator, which is able to generate a sinusoidal signal. And that's the buffer, and it's used to amplify the signal from the sine wave generator. We need this because I don't think the signal from the sine wave generator is sufficient for powering up the driver. So after using this buffer, the signal will be strong enough to let the driver work properly. For the main skeleton of this whole structure, I chose to use industrial aluminum profile, which is quite light and also quite cheap. And the clamp is also made of aluminum. So these are all the materials that I need, and then the construction begins. First, I cut off the unnecessary parts on the speakers, like the 2 metal parts on each side, and also the diaphragm, because they can really get in the way when you are putting the tube on it. And then I put the tube onto the speaker and use the ultraviolet glue to stick them together. So this is a picture of our Coriolis Mass Flowmeter sensor after everything is connected. And then I try to find the resonance frequency of the tube. For the two pictures, at the bottom, the upper wave shows the signal that is given to the driver, and the lower wave shows the signal from the sensor. And as you can see, the left one is not in phase and the right one is in phase. Also, the signal from the sensor in the right one is also much larger than the left one. So I think we have found the resonance frequency of 246.4 Hz. Because there's some damping caused by the basket on the speaker. Well, the basket means those cloth-like thing around the coil of the speaker. So I tried to cut it off, which had proven to be a big mistake. And as you can see, the slit for the coil to be put in is actually very small. So if we did not put the coil exactly at the center, then there might be some friction between the coil and the magnet or the outer structure. Then the signal that we get would be distorted and the signal will be useless. So it's a rip to this one. However, this is not going to be the end of my project. In the next video, I'm going to try to find a speaker with a wider slit. But this data is not usually shown on the websites, so I have to buy a lot of them and test them one by one, which would be quite annoying. And also, I will make another improvement. I'll try to make the speakers adjustable in their position, so I don't have to worry about not placing them in the correct position in the first place, because I can adjust them if I find that something is wrong, and I don't need to make another one. Finally, the acknowledgement, and I would like to express my special thanks and gratitude to the Department of Control Science and Engineering of Zhejiang University in providing some assistance. Well, actually, I have already finished the project, but as I'm a student, I really can't find too much free time for making videos, but I'll try to make the next video as soon as possible. And I know it's not been a great video, but if you really like the content, please consider clicking the like button and subscribing to my channel. And if you have any comments to make, please add a comment in the comment section, and I'll most certainly read it, and I'll try my best to reply. Thanks for watching. Bye bye.